Lulea, Sweden, the cold winter is a challenge for everyone. Through user involvement, teacher and researcher offices now support advanced solutions that save energy by adjusting to user habits. And in the snowy parking lot, a new generation of intelligent car heaters that know when vehicles will be needed has led to extraordinary savings.
We have a bunch of projects related to energy efficiency and energy smartness, if you say. Most of them, or all of them, are quite much working with advanced information and communication technology and what that can do for better energy systems. And one of the overall important aspects and emerging needs is, of course, to be able to use renewable energy, wind and solar, for instance. And those sources are more irregular, more going up and down depending on the wind or the sunshine. And we can't control the sun or the wind very much, so we need to control the consumer side. So the purpose with some of our projects is to actually learn in what way we need to control it and how we can control it. Basically, what kind of changed energy behavior we can accomplish with the energy users.
So what we are trying to do is to find what motivates the users, the people, to save energy. And what we have seen is that if the participants can themselves be a part of constructing or designing the savings ideas, then that's a great motivator. And that's also part of our Living Labs approach, to really engage the users in identifying and in suggesting the ways to change, as in this case, saving energy.
I actually use this every morning. I'm usually the first at the office. So I actually have a look each morning when I arrive, just checking, because it should be black when I arrive. If it's not, something is left on. So I actually use this one to have a check on what is the current power consumption. Have we left something on? Should we turn off something? Well, it's a very good way of directly seeing when you turn on something or turn off, you directly see the result.
At the university, we are using a method called Living Lab in many of the research projects that we carry out. And we do so in the Smart Campus as well. Well, what we saw when we started our research was that very often we involved users in the end of the development process. So when a product or service was finished, then we asked users to test it, see what they thought, if it worked, if it was related to the needs that they felt, and if they felt that they had a need for the product. And of course, we learned a lot about things that could have been done differently. Functions that didn't exist, and that they said it would have been great if we could have done this, or if it worked in this way. And therefore we started to say we should of course involve users from the very beginning of the process, also already when we think of the idea for the product, conceptualization, prototyping. And that's what we do in Living Lab. So for instance, we have implemented car heating systems. And due to that, people don't have to think, how would it be to use a smart car heating system? They can actually use it, and they can give us their opinion on what was the consequences, how can it be done differently, and was it something that they felt they really had a need for?
I think it's great because we can save lots of energy, and I'm engaged in environmental. My car is an eco car, and I think that it's good that we can save energy.
Okay, so this is the car heater part, the car heater experiment of the Smart Campus project. As we know, in North Sweden in the midwinter it's necessary, it's almost mandatory to have car heaters to be able to start the car when it's like -20 or -25 degrees. The previous heaters that were used, or the previous outlet that were used, were of the kind that were on 24 hours a day. And that of course made for a nice and warm car, but it's a waste of energy basically. it's an unnecessary use of energy. So what we have now is a modern type of heater outlet that you can program on the internet and what you do is you enter the time of departure of your planned departure, and then the car heater switches on a suitable time before this, depending on the cold.
It's very practical for us employees that we can via internet start the heat, and then the system fix the rest.
Usually you can save up to 80% compared to a traditional system. Here we can see the energy consumption of a traditional car heating system, and the red line shows the energy consumption for the same area after our smart car heating system is installed. The new system we developed and is being tested now by Smart Campus has another benefit in that it uses RFID as an identification system. So you no longer need your own personal parking space, but you can park at any free parking space and identify yourself with the RFID tag. And the system then knows where you're parked and makes sure your car is heated for when you need your departure.
On the picture here we can see how the electrician consumption are for e-building. As we can see here for 2013 we have an increasing electrician consumption. And if we go to 2014 we can see for the 2 first months we have a decreasing consumption. Some part of that is because of the heating pilots, and the payoff time for it is looking really good.
I will shortly describe how the system setup is. The Smart Campus pilot in Lulea consists of the Center for Distance Spanning Technologies offices. They have 2 offices, and in each office the electricity usage for the computers and lights is measured. So in total you have 4 electricity meters. The meters are connected to our measurement system Saber, and from there to a centralized database where it can be accessed by all the European partners through an application interface. In addition to the meters inside the office is also electric car heaters. The measurements from these is transferred to our system once a day. All the data is also shown on real-time visualization screens in the office.
The European projects are very valuable. It's very interesting to bring together people from different parts of the world, different parts of Europe, and from different categories. I mean, we are now at the university, and there are also some SMEs and some larger companies involved, and it's very important to bring them together to explore the possibilities for innovation that can come out of such collaborations.
Everyone have heard of global heating, and this is related to carbon dioxide emission, and it's directly related to energy consumption patterns. So helping and improving our ability to use renewable sources is very important. That's one of the reasons I think this project is important. The other thing is kind of what we and our colleagues in Europe are expertise on, and this is advanced information and communication technology with sensors and the way we can interact between the environment and the users of the environment to make them understand and in a good way make them change their consumption patterns.